We are discussing Cbse Class 10 Maths NCERT textbook, 6th chapter Triangles. And in this video, we are going to discuss the theorem 6.2 here. In the previous videos, we have discussed the theorem 6.1 also. 6.1 is nothing but the basic proportionality theorem. And this theorem 6.2 is the converse of the basic proportionality theorem. So that is the basic proportionality theorem or the Thales theorem, and this is the converse of it. Okay. In the basic proportionality theorem, we saw that if a line is drawn parallel to one side of a triangle, so if we have a triangle and if we are going to draw a line which is going to be parallel, it will divide the other two sides, and it will intersect the other two sides at distinct points D and E. That is what we saw here. Okay, so we had A, B, C, and we had D and E, and this was given. Okay, and we were asked to prove that the other two sides are divided in the same ratio. So under the BPT theorem, the given data was that DE was parallel to BC, and we had to prove that it was dividing in the same ratio. That is AD by DB is equal to AE by EC. Here this is the converse. Converse means what? Whatever was given in the previous theorem becomes what we have to prove, and whatever was given as to prove becomes what is given. So that you can see here. Okay. See, look into the statement of theorem 6.2. If a line divides any two sides of a triangle in the same ratio. See, this was given. So same ratio is what? AD by DB is equal to AE by EC. So this is given. Then the line is parallel to the third side. So this is the given statement, and in the given statement what we have to prove here is that this line is parallel. So this becomes what we need to prove, and this is what is going to be given. Okay, here we are doing a small change in the old diagram. So previously we know that DE is parallel, but now we do not know if DE is parallel or not, because we have to prove that DE is parallel to BC. So in order to prove that, what we are going to do is, we are going to assume that we have another line DE dash. Okay, we are going to have another line DE dash, and we are considering DE dash to be parallel to BC. So this is our consideration. So we are going to consider DE dash parallel to BC, and we are assuming that DE is not parallel to BC. So our assumption is what? Our assumption is that DE is not parallel to BC. Okay, so this is what is our assumption and what we have considered. Now, we are already given that AD by DB is equal to AE by EC. If DE dash is parallel to BC, okay, under this consideration, if we apply the Thales theorem, then we can say that AD by DB is equal to AE dash by E dash C. Okay, but we are given that AD by DB is equal to AE by EC. So this is what is given. Okay, and this is our consideration, what we have considered, or our assumption. Okay. Now, when we compare these two, we can say that the left hand side, that is AD by DB, is common here. So we can equate the right hand sides. So I'll get it to be AE dash by E dash C is equal to AE by EC. So till this we are given even in our textbooks, and after that the proof is not completely given. So here I'll discuss with you the proof completely so that you also understand it completely without any further doubts. Okay, so for this what are we doing here? We are adding 1 to both sides. So now let us do this here. So AE by EC plus 1 is equal to AE dash by E dash C plus 1. So you can cross multiply, so you will get AE plus EC by EC will be equal to AE dash plus E dash C by E dash C. Now compare the diagram with this statement. See, we have our A is here. So AE plus EC. AE plus EC is what? This is going to be AC. Likewise, AE dash plus E dash C is also equal to AC. So from this we can write AC by EC is equal to AC by E dash C. So we can cancel these two and you will get 1 by EC is equal to 1 by E dash C. So from this when you cross multiply you will get E dash C is equal to EC. So this is what we have got. Now coming back to the diagram, if E dash C and EC are equal, then it means that both are going to overlap. E dash and E are going to be the same. So I can say my E dash is equal to E. Okay, so here with this we can say that DE dash is equal to DE. From this we can say that my DE is parallel to BC. So our assumption where we considered it not to be parallel is going to be false, and we are able to conclude that this line is parallel to the other side. That is, the line is parallel to the third side. Which line? The line which divides the two sides of the triangle in the same ratio will be parallel to the third side. Okay, so hope you have understood this video. Once again listen through the video and please read through the textbook and try to understand. We'll meet you again in another video, children. Thank you, children.